So last week we started talking, actually not started, but we just continued talking about IP layer. Then we talked about why we moved toward IPv6. Then we talked about different classes of the IP. If you remember, we talked about class A, B, C, but then we said we have class E, D, and E, but we didn't talk about it because I said it's not important really to know because they are not common. You don't see really, you're not going to talk about it or you're not going to be asked anything about those classes. Then later at the end of the class, we started talking about the subnetting IP address. So I'm going to review some of the slides that we talked last class, and we remind, basically, I remind you what we talked about, and then we continue talking about subnetting. So we talk about IPv4 addresses that basically is 32 bits. It's consists of the network portion. Then we said it consists of network portion, host portion, but then we talked about subnetting. So basically what we're going to talk today more is like this line that basically can be moving around this part, okay? Basically you can have more subnet portion, then lower host, or lower subnet portion, bigger number of hosts. We're going to talk about it, don't get confused for now. Then about the IPv6 addressing, is we mentioned it's 128 bits. Basically, it's going to be something like this. When we're talking about subnetting for IPv6, we're going to talk about that too. But just remember that basically there are like this global routing prefix. This usually is 48 bits, but depends, sometimes 40 bits. Then we have subnet ID, then we have interface ID, which is like more or less same with the host portion. Then we talk about that early, when internet started, the network was flat. They were assigning the IP address based on the classes, like class A, class B, class C. Then basically they realized it's not going to, there's going to be problem with assigning IP addresses because they ran out of the IP addresses. That's why then we had this basically subnetting. Then IPv6, those are basically afterthoughts. Then we talk about that there are certain reasons that we do subnetting. We mentioned, like, for example, you want to control the traffic by containing broadcast traffic. You mentioned if you have a subnet, you remember you have all the basically main network, and you have smaller subnets under that main network. And we mentioned, for example, let's say control traffic like broadcast packets, if we just circulate in the subnet itself, it doesn't need to go out of that subnet. So basically it's like we creating a smaller broadcast domain. We provide low level security because it makes it easier for us to control even the security. We limit the amount of traffic on the other end of the network. So basically the traffic can be maintained inside this subnet to a big extent. So those were basically the reason that we do. So then I mentioned that subnet and network can be, in this class I can use either of them, so but it means the same thing. Then we talk about that basically if this is the view of your ISP internet provider or your network, you have this router that's connecting you to basically outside to the internet provider. Then what the internet provider sees from you is like, this is your IP address, because this would be the IP address basically of your network. And it's going to be basically seeing your network prefix here. We talk about it, what does it mean? But we said what's happening inside this network, then it's somehow is hidden from the ISP internet providers. So here, this is basically the network prefix. So here, what is happening here, for example, here we have different, like for example, 5 different subnetworks, right? And each subnetwork is in the network, in net prefix of 24. We talked about it, but don't get confused again. I'm going to talk about all of them again with examples and things, so it's hopefully making it more clear. So we talked about it, then we mentioned basically subnetting, you can see it as as this very sensible example. You have 100 apples, then it's totally up to you how you want to divide this 100 apples. It can be 10 basket of 10 apples, it can be 5 basket of 20 apples, it can be 5 basket of 20 apples. The last basket can be 2 basket of 10 apples, okay? So basically that's exactly what's happening with the subnetting. We have all this bunch of basically a series of, let's say, IP addresses that we can use, this range of IP addresses that we can use. So we're going to divide it, basically, we're going to making it look like a hierarchical structure. Then we mentioned this example, if you are the one that's designing the network of an organization, so you need to consider certain things for deciding how you want to do subnetting in basically in that organization, whatever it is. It's a small company, it's a university campus. So it's important, for example, you know what is your number of the hosts that you require per subnet. For example, you say, okay, I need, for example, 16 subnets. Each subnets, I need at least, I don't know, 500 hosts. Or they tell you, for example, I need, I have like 16 departments, okay? So I want 16 different subnets, and they don't tell you how many hosts they want. So you just consider the subnet in order to do the number of the basically subnetworks. Then you're going to use that in order to do the subnetting. So, okay, this is that I skipped last week. I want to talk about it today. We talked about that IPv4, basically, they ran out of the available IPv4 to assign to new devices, new services. But it's still, I mean, how can I say? Okay, we are still using it, right? I said there are a lot of systems that are using IPv4. Still, according to that example I show you in the Google, we are using still 70% of the basically people in the world, they are using IPv4. So how we can still use IPv4? I said there are certain ways that they coexist with IPv6. But another reason that we can still use IPv4 is due to the NAT or network address translators. I'm going to talk about it. Basically, what it does is basically, and also to private addresses. For example, you know, in your system, in your computer, most probably, you have a router in your house, and then you connect your laptop, mobile phone, yourself, or your family's basically devices to this particular router. But usually, most probably, you have seen that there are certain, for example, this type of IP address there. For example, 192.168, for example, 0, I don't know, 10, for example, is your phone, then your, I don't know, your sibling phone is, for example, the IP address is 192.188.0, like 20. But those are like basically private address, okay? Those are not public address. You remember we were talking that each device that is connected to the internet should have a unique IP address, right? But if that's IP, pardon? Sorry?
No, I was just telling you that I agree with you.
So, okay, so if you agree, then this is the range that, for example, you're going to see in your router and your system, in your computer, and your phone.
Right.
This is exactly the same thing I'm going to see in my computer. I see the same IP address, and like millions of people in the world, they are using the same thing in their house. But the thing is, yeah, of course, they are not unique, but they are just private addresses. They are the address that used in your house or in your, I don't know, small offices or whatever it is. They are private addresses. They are not public addresses. So how then you communicate with the internet through these network address translators? So basically, your packet goes to the router using this private address that you have. Let's say 192.168.1.2. It goes to the router, and router convert that to the basically send the packet through the network to the internet through your public IP address. So the public IP address that you have, or that unique one that no one else has in the world, is basically the IP address that's assigned to your router, not to your phone or your computer that you're at your home. So that's basically the public IP address. And so basically the router forward the packet to the internet using your public IP address. And then when the packet response come back to the router knows, for example, it was your phone that requested this packet because of they have this NAT forwarding table inside the router that define, for example, this packet was from this port, that port is dedicated to your particular, for example, phone or your laptop. So that's how basically it realized basically the packets coming from which basically deposit, which device that is connected to that. But remember, we are using these public private addresses. So those private basically IP addresses are not announced to the internet. They are totally private. That's why still we can use basically IPv4, even though we ran out of it. Okay, somehow even before we start using IPv6, we had more number of devices that are connected to the internet, more than 4 billion for sure. Okay, but still they were using IPv4 due to this, because this would make IPv4 still possible. Because, for example, I have maybe around like 5-6 devices in my house connecting to the internet, but all of them, I have just one public IP address. Is it clear?
Yeah.
Yes.
And that public IP address is basically the IP address that is in my router. All the other basic devices are using the private addresses. So there are certain ranges for private addresses. These are basically range for private addresses, 192, 168, 00 to this, which is you can have 65,000 IP addresses. Or this range that is like 1 million IP addresses can be there, or this one that is 60 million IP addresses can be there. Those are basically used only privately. Okay, they are not circulate in the internet. Those packets are not, the packet goes but through the public IP address to the internet. So those ranges are for private addresses. So this is the most common one that you see in our houses, right? You have seen this in your routers, in your laptops, everywhere you've seen this range of IP addresses. So basically, these two are the same. Okay, here I show you with the subnet mask. Here I show you the range. Okay, so basically these two lines exactly mean the same. Okay, if you put this using this subnet mask, you know you have here 16 bits. Okay, for your host address. So here you have 8. Here you have 8. Do you see my mouse when I'm moving here?
Yes.
Yeah.
Yes, teacher.
So okay, let me put this way. So you have 8-bit here, 8-bit here. So basically you have 16 bits for your host address. So 2 to the power of 16, you get basically this number of IP addresses. So this is the same thing. So these are the basically private IP addresses. So I don't know, like you can do the same if you're connected with your laptop or something like that. You can go to your command line right now. It's fine to do that. Let's take like 2-3 minutes, do that experiment. Go to the command line in your Windows, if it's Windows or if it's Mac, go to the command line and check like ipconfig command. So the command would be, ipconfig. That is basically ipconfig for Windows, and I was checking that would be ifconfig for Linux or Mac. So can you check it right now and see what range of address you see there? Okay, I'm pausing this resume recording. So you see, basically we are having a public IP address, which would be our router. Then there can be like, I don't know, 200 something device connected to that, but all of them are going to have a private address. Okay. Any questions so far?
No.
No.
So one thing maybe you need to remember here, of course, you need to remember how does it work. You remember, I don't remember before we talked about NAT, but now you know how it works. Network address translator, translating the private address to the public address. And then remembering, for example, this packet coming from this private address, it goes to basically NAT's forwarding table, then it goes to internet comebacks, then it comes to your phone. It doesn't go to your other phone, okay? Because of that. So, oh, sorry.
Teacher,
Yes.
so when you send a a packet, the destination IP is the public one?
I didn't get your question. What?
When you send a packet in your computer or cell phone or whatever, the IP destination address is the public one.
Destination address is the public one, of course, yes. Yes, because, for example, if I know, for example, most probably you're going to have this in your phone, like most probably all of you are going to have this as your like 192.168.0.1 or 1.1 as your default gateway. That's your private address, but even knowing that, I cannot communicate with you because that's private address most probably for another 10 million people in the world or for a lot of people. And I cannot even communicate with that because those type of packet that are addressed like this, in this range, it doesn't go, I guess literally they don't go out of your router. Okay, they stay inside your neighbor, in your network. So let's proceed. So for having a subnet, okay, basically a router is required to subnet a network. For example, you have a network one here, which has two different subnet inside it, and another network two here. So basically, you need each network requires their own router, of course. Okay, and each subnet should be connecting directly to the router. For example, this subnet cannot be connected to this subnet and through this subnet to the router. Okay, so each subnet is directly connected to the router. So basically, that's how it works. Okay, but it's a noun literally. So this is the same thing I said. There are two considerations when planning a subnet. You want to know what are the number of the host address required for each network and the number of the individual subnet needed. As I mentioned earlier as an example, for example, take Campus Guadalajara comes to you and say, okay, I have 16 or I don't know, I have 10 standalone building in my campus, so I want 10 different subnets. But how many these subnets have hosts, I don't know yet, okay? But I just know I need 10 subnets. So then you can basically plan that network based on that. Or for example, they tell you, I don't know how many subnets I want, but I want like a maximum like 200 hosts per subnet. That way also you can do the planning. And we're going to talk about it, how you can do that. So another point you have to remember, there is an inverse relationship between the number of subnet and the number of the hosts, because the more bits you assign to your subnets, there would be less bit for your host part. It means the more subnets you have, lower hosts you can have. The lower subnets, bigger host number you can have, because there are certain limits. Basically, you want more subnets or more hosts. You're moving between these two. More subnet basically means lower host, lower subnet means a higher number of hosts. So there is this inverse relationship between these two. So So as this example that I said, for example, sometimes a certain number of subnets is required with less emphasis on the number of the hosts. The example that I just mentioned. So let's talk about how we calculate, okay? So from now on, it becomes not confusing, but pay more attention what we're talking about. So remember this example that we mentioned earlier. This is the ISP. This is the router that connected to the ISP. This is basically the ISP address that the address that ISP basically defined to you, assigned to you is like 150.50.00 with the net prefix of 16. What it means, basically, you have all this range of 2 to the power of 16 IP address, which is like 65,000 IP address to play around with. Let me clear it, okay? So if this is the IP, this is what you have 2 to the power of 16 IP addresses. So imagine like that Apple example, you have 2 to the power of 16 Apple. Now it's really totally up to you what you want to do with that 65,000 Apple. You want to put all of them in one giant, I don't know, barrel, it's fine, you can do that. You want to divide them to 120, you can do that. It's totally up to you. So what, for example, here we see, for example, let's say the administrator decide to have 5 different subnets. Okay. Or design, basically, I can say design decided to use this 8 bits here as a subnet mask. Okay. So basically what it means, okay, I'm going to use now 8-bit as for my subnet for my networks, okay, because I want to have different networks, and I'm going to use 8 bits as basically the host for my host. What it means, basically, you're going to have 2 to the power of 8 number of subnets, 2 to the power of 8 number of hosts per subnet. Okay, don't confuse that. So for example, here we have this network, which is 150.50.10. Okay, so imagine again, there could be totally one person sitting here managing this number of basically IP address that he has, as I mentioned. Okay, again, you can divide it to even a smaller network. You can say, okay, I have this range of IP address, 2 to the power of 8 here. I can play with. So I want to divide it to 4 networks of 16 hosts each network. It's totally fine. So let's look at this example here, what's happening here. So here we have, again, like I mentioned, like we have, for example, these subnets, that each subnet has, again, can have certain number of hosts. So this is the IP address. Okay, this is, we're talking about this one. Okay, remember with 16 base network mask. So basically, this is the IP address for the network part. Still, this is all the IP address of the network parts, our network, let's say for our campus. With this base 16, so basically the 8 bits here, 8 bits here, 8 bits here, 8 bits here. This is this one, this is this one. Then now we can use basically subnets of this. Okay, the one that I show you, the 24, the previous example. Here you can see the subnets mask that we are using here is 24. To have different networks. So now this is our subnets. Okay. So we can have all the way from 0 to 255. This is the second bit here. Now this is what we are using here, okay? Because now we changed the mask. This is the one now we are using. This is our subnet mask, okay? I'm just repeating it over and over. I'm just want to make sure you're not confusing between these two, okay?
Right.
Is it clear or it's confusing?
Oh, no, it's clear.
Okay. So we can have now this number of subnets because this is now, it's part of our subnets, and now we are using this prefix. Then we have 2 to the power of 8 as a subnet. And then we have the host section too, right? So we have basically 8 bits as the host section now. So here for each subnet, we can have 2 to the power of 8 host, or 2 to the power of 8 computers can be connected to each subnet. Is it clear?
Yes.
Okay, so let's proceed. So basically it's the same thing. So we have all the subnets, okay? Then this is the range of the IP addresses that we can use. You remember I mentioned before that all zeros cannot be used, okay? So that's why we are here starting from 1, like 151, 150, 50, 0, 1. That's our first host. This is the IP address of our first host, because we cannot have 150, 50, 0, 0. That is reserved, I mentioned. And another thing that you need to remember is 150, 50, 0, 255 is not also allowed. Why it's not allowed? Because 255, if you remember, it represents all 8, all 1. This is basically a broadcast address. All 1s are broadcast address. So this is basically, sorry for my bad writing. Like
yeah, don't worry.
This is 0, this is 0, this is 50, and this is 150. Okay?
Yes.
So this one, this IP address, in this one, this IP address basically, this is point, okay? This is point, this is point. This IP address is a broadcast address for this particular subnet. You have a broadcast packet you want to send to all the hosts that are connected, you're going to use this. So you don't assign this to any host, not this one and not all 0, not all 0 that you have 80000. Those are basically reserved address. So the number of the hosts that you get, I told all of that to reach to this. You have 8 bits for your host, 8 bits for your host to use. So the number of the hosts that you get is 2 to the power of 8 minus 2, of course, because you cannot use all 1, you cannot use all 0. So you lose 2 addresses, so you get what at the end you get 254, or 2 to the power of 8 minus 2. Is it clear?
Yes.
If there is any question, doubt, please ask, because it's gonna get even more confusing. Okay, if you don't get this one, then later it's going to be more confusing. So let me erase all. So what it's showing here is basically, this is the first IP address for my subnet, and this is the last IP address. Basically 150.50.0.254 is the last one for this subnet, for subnet 0. Then this is my broadcast address. So let's go. So, okay, let me see what I wanted to tell you here. Okay, so if this is the host IP address that we have, okay, if this is the host IP address, so and someone asks you, so what, basically which network this host, this IP addresses belong to? That can be very valid questions, okay? So this is the network that you have, right? Because the prefix is 16 here. So this 16 here, you can locate this one. It means these two are network, okay? Right? The first 16 bits, that's what it means. So this is network. This is the first host that you have, 150.50.0.1, because you remember the 00 cannot be here for the first host. Last host is 255.254. Remember, 255 means all the 8s are 1. All the 8 bits are 1. That cannot be allowed. So last host is 254. your broadcast address is this. It's true.
Right.
So basically, what it tells you that you have one network here, and you have all this number of hosts, 2 to the power of basically 16 minus 2. That's the number of the hosts that you can have with this host IP address and this prefix.
Teacher, can you ping a broadcast?
You can ping a broadcast. You can ping a broadcast. I don't know, really. I don't want to answer answers. I never thought about it. If you can ping this IP address.
Yeah, because I wouldn't know what you would receive, right? Like.
Yeah, I would say you can do that. I would say you can do that. Most probably it's going to go just one round to the nearest one, or just maybe pinging yourself, something like this. I'll try that later.
Okay,
so,
thanks.
No problem. So let me remove this. So remember this. Let me go back. Let's see what's happening here. This is this IP address. Okay, my prefix is 16 here. But if I give you this, okay, this is again totally valid question. I can ask you which network this IP address is belong to, or what is the situation here?
It belongs to 150.50 in the 4 subnet, or the .3 subnet.
True. So here now, this is the same thing that we used earlier. Okay, that still we are continuing with that ISP example and that things. So basically here now you have this prefix of 24. It means that even this part is part of the basically network now. Basically now it means this is now your subnet. So if you do the same thing that we did last time, so this part was basically your the original one network. Now this is your subnet, and this part is your host now. So this particular IP address is belong to this subnet, right? This is your subnet. It belongs to this subnet, and this subnet has the IP address in this range from 150.53.1 all the way to 254, and the broadcast address is this. So how many hosts you have? Let's say first, how many subnet you have here? If I give you this, how many subnets you have?
2056.
256, right?
200.
Yes. All the way from 0 to 255, right? This is because you have 8 bits. Simply you have 8 bits, you say 2 to the power of 8. I have 256 subnets from all the way from 0 to 255. Then you have 8 bits for your host. Basically, it means you have 2 to the power of 8 minus 2 hosts per subnet, right? So you have 254 hosts per subnet. As you can see, this is the range. This is the first host, and this is the last host. So this is a range. Okay, this is not just 2. This is a range: 150, 53, 1, 2, 3, 4, 5, all the way to 254.
Right.
So the same thing that we discussed. Okay, the good things here, like interesting thing here is like we said you have this many subnets, right? This is your subnet, 256. Then we said you have another 256 minus 2 as a host, right? Per subnet. So in order to know you how many system you can base, or how many in total IP address you can support, is you multiple this 2, you get 256, multiple 254, you get 65024. Basically, that's how many IP address you can support how many hosts in total your network can support. It's clear?
Yep.
So remember, this is not 2 to the power of 16. Because of that -2 here, we are losing certain number of IP addresses. Clear?
Yeah.
Okay. So let's move on. Okay, to calculate the number of subnets or hosts that are needed, I mean, this is the same thing that I keep repeating. I just put it here. So let's say this is the IP address. This is your IP. Okay. This is the subnet mask. Or this is the same thing. This is the same different way of showing it. So this is a question for you. So they come to you with this setup. Okay. Just for now, forget this part. This part, forget it. Up, forget this part. Just look at the questions. They come to you, they say, okay, this is your IP address. This is the basically subnet we have. So they want like 60 hosts per subnet. This is the range of the IP address that you can use. They come to you with this, even you don't need to see this because it's the same thing. They come to you with this and they say, okay, I want 60 hosts per subnet. How should I manage my network now? So what is the answer for this question? So remember, they don't tell you how many subnets you want. They say they want 60 subnets per host. 60 hosts per subnet.
Maybe,
Yeah.
maybe we can concentrate like something like 2 to the
I don't hear you. You are mute.
I was saying that 2 to the 6 is 64. So we can leave the last 6 bits as host part and the other ones as the subnet mask.
Okay, so you say you want to define, you want to dedicate 6 bits for your host, right?
Yeah, because it's 2
Okay,
to the 6 is 64 and -2 you can connect 62 hosts per.
And how many subnets you're going to have? In that setup, how many subnets you're going to have? Kevin?
Well, I was making a little calculation and apparently are like 26 bits of masks.
No. This is all the range that you have. Basically, okay, that's what I'm trying to say, not to confuse you. This is what
Okay, and
all the things you have is the last part to play around with.
Okay, that is the net mask of our general.
Okay, you're correct. I mean that basically that's what you said is correct. So this is the IP range that you have. Okay, this is, let's say this is coming from your ISP. You have these 8 bits, or you have 256 IP address to play around with. 256 Apple to divide whatever you want. Okay. So, but what I'm telling you, I told you here that I want 60 Apple per basket. Okay. That's what I said. Now, how you want to divide it is up to you. So Kevin said, okay, I want to separate like 6 hosts, 6 bits. I want to dedicate the 6 bits, the last 6 bits basically for the host. So I can get 64, then you are -2, 62. So that is satisfy my conditions. Then these 2 bits will remain for for the host, right? So you have 2 to the power of 2, which is 4 subnets. So you have 4 subnets. Each subnet can have 62 hosts connected to it. It's clear?
Yes.
So basically, this would be your network. That's how your network would look like. You have these 2 bits here as the subnet. So now your subnet would change to this, right? Now, because now if I tell you your network would be now /26. Because these 2 are now defined for basically a subnet. So this would be your 4 subnet. This would be the first one, second one, third one, and fourth subnet. So the first subnet IP address is going to be 192.168.1 dot basically 00. Then this is the part for your host. So you're going to have here, this is 26 that I was telling you. This is going to basically start from this. Then the second subnet is going to start from this, start from basically 64. So you remember, okay, let me again say something to don't get confused here. This is the IP address you're going to start with. Because this 2 part is 0, so your IP address will start from 192.168.1.0. This one is not your choice. This is the come from basically here. This is
Okay.
So these first 3 parts are the one that basically you have. So all the thing that you had was this last 8 bits to play around to divide it whatever you want. So the first subnet start from 0 all the way to 63. The second one start from 64 all the way to 127. Second one start from 128 all the way to 191. And the last one start from 192 all the way to 254. Right?
Okay, yes.
Is it clear?
It's perfectly clear for me.
Okay, glad to hear that. I hope it's clear for all of you what's happening here. So the whole idea was you have the last bit to play around. Basically, you had 8 bits in this particular example. You had 8 bits to play around with. So, and that was the requirement to have 60 hosts per subnet. So that's how you decided to do the subnetting. So another question. Now you have this. So I want this one.
We could use 3 bits for the host part, right?
3 bits.
Yeah, 3.
So 3 bits gives you how many hosts?
It would be 15, up to 15 minus 2 would 13.
3 bits.
No, that will be 8.
2 to the power of 3 would be 8, right?
It can be 4.
So yeah, Uncle, you're wrong because you said 3 bits. 3 bits, you can consider 2 to the power of 3 going to give you 8 different variation, right?
Yeah, right.
So you go 4 bits. So the 4 bit 2 to the power of 4 gives you 16. If you consider this minus 2, so you get 14 hosts at least. So that's exactly how you do again. So
Yeah.
how many? Okay, you said 4 bits. You're going to define 4 bits, dedicate 4 bits for subnet, for basically your host part. Then how many hosts how many subnets you're going to have?
16?
16?
Because it's 4 bits of host and the other 4 bits to
yeah, exactly. So basically, as you said correctly, it's a 4 bits for the host part because you want this one. Then this would be remaining for your network part. So now this would be basically the things. Now you have 240 here, because if you add this in decimal, it gives you 240. Okay. So now the prefix that you get is, what is the prefix you get for your subnets here?
28.
27.
28. It was 24. Now you have 4 here, so you get 28 here. So that would be basically how the network forms. I put everything here. So that was the original one. This is now your network. So the first network is so for your network, you're just changing this, okay? So you have one network that starts with this address, with this one. Your second network starts from this, with this. It's the third one starts with this. So, and each one has their own basically range of IP address. So this one starts from 0 goes all the way to 26, because 27 would be broadcast address. This one goes from 16 all the way to 30. This one goes from 32 all the way to what is that? 46. So basically your host now is increasing 16 by 16, right? Because you just select 4 bits. So is there any questions so far?
No.
Is it clear? Anyone has any doubt, any confusion?
No, it's clear, teacher.
Okay, perfect. So let's go on then. Okay, any other questions? This is your IP, the same thing. So now I'm not telling you the host, I'm telling you I need 6 subnets. I have 6 offices, I want to give each one of them one network. So how should I do?
I would say 3 bits for the subnets and the rest for the hosts.
Okay, how many hosts you can have per subnet? Per network, basically, let's say per network.
2 to the power of 5.
Exactly. So yeah, but remember now, when you're separating here, now you're separating from this part, right? The first 3 bits. You're not going to do these first 3 bits here, right? Because that's a host part of it. So now you're going to say, okay, I want 6 subnets or 6 network, because I have 6 different offices. I want to give each one of them one network. So you say, okay, I need 6, basically 3 bits for my 6 subnets. So you say, okay, this is my subnets now. This is part for my host. So then you get the prefix of basically 27, because you had 24 earlier. Now you have 3 more ones, so you get 27. So this 27 again means all the ones that you have here. You have 3 here, you have 8, 8, 8. So in total, there are 27 ones. So this is basically your...
Teacher.
Yes?
I don't understand that one. When you're talking about the network needs 6 subnets, it's different than the last one. So
okay.
I think I get confused.
In the last one, in the last example, what we're talking about here is I'm telling you I want 12 hosts, okay, per network. So you can look at it like, okay, I want 12 apples per basket. So I don't care how many baskets you want to design. I want to have 12 in each one, at least, okay? So we said, okay, these are the bits that I'm able to play around with, okay? So I separate four bits for mine as my host part, okay? Then I have 2 to the power of 4, so -2, then I have 14 hosts. I can define 14 hosts. For the other one, here we are talking about, here we said, okay, I need 6 subnets. So I'm telling you, I need 6 baskets. You have all these apples. I want you to put them in 6 different baskets. But I'm not going to even calculate how many apples would be per basket. I said 6 baskets. So you say, okay, this 6 means like I need 3 bits here, because 2 to the power of 3 means 8. So you get these 3 bits here. So the remaining would be for your host. So you have now 2 to the power of 5 minus 2, number of the host. And this is your number of the subnets. Then this 24, as I mentioned earlier, this 24 comes from, basically is the range of IP address. Let me say it in a plain English. It's a range of IP addresses that you are allowed to use, that is given to you by the ISP. And ISP going to see you with this. No matter what you do inside you, no matter you put the prefix 27, you put 6 subnet, you put, I don't know, 60 hosts, no matter what you do inside here, this is going to be always seen for the ISP. ISP going to see you by this. But how are you managing that? It's up to you totally. So that's why I said this 27 now is basically new subnet mask that you have for your network. And still your ISP going to see you by this. But this is the net mask that you have inside your network. Because now this, you remember this number, we said this 24 comes from number of 8. 255 in decimal means 8 consecutive in a binary. So this is 8, 8, 8, and 3. So in total, it's like 27. So that's the same thing. It's same thing that I write it like this. Okay. Or I write it like this or like this. They're exactly the same thing, same meaning. Any other questions so far? So if you remember, this is number of subnets. Now we have 3 bits and 8 bits. We have 3 bits for subnets, which means 8 subnets. And we have 30 hosts, because 2 to the power of 5 means 32 minus 2. You have 30 hosts per subnet. So this would be something like this. So you have 8 different subnet here. These are all the 8 subnets for you that is starting from 000, 001, 010, 0. You see how you're basically you're just considering this tree and you're increasing it. And then for your range of the IP address, for the range of the host, going to jump 32 bits, 32 per 32, because you have 5 bits here. Okay, it was good timing. So I want you to do this So I want you to do this activity. I'm going to, let me first share this with you. Show the name, copy. Can you open this, all of you, in your system? You can have like a piece of paper next to you, or you can just write it in the PowerPoint itself. So what I'm going to do is, like, we have 13 students. I'm going to divide you into group of 3s, and you just think about it together. Complete this one and this one, this exercise and this exercise together by thinking together. Then we come back here and we discuss about it. So let's give you 10 minutes, okay?
Teacher,
Yes.
the presentation is in Canvas?
No, it's in a Google Doc.
No,
I
no,
sent
but
it.
the presentation of the topic, not activity.
I will upload it. Yes.
Okay.
Yes, of course. I did it last week. I'm not telling you that I'm uploading, but if you check this, it's every week I'm uploading. It's constantly I'm uploading. So take this, open it in your. I'm online. I'm going to come to your basically each group. Then we talk there. Let me stop sharing this. I'm stopping. Okay, I'm recording now. So yeah, I could guess it would be confusing, but yeah, that's. I mean, when you hear it, then you feel it makes sense, and okay, you're understanding it. But then when you're trying to do it, then you say, oh, that's how it works now. So let's look at the answers, how it is. So the idea here is this is the IP address again that assigned to you, let's say. And you want to divide it to 6 subnet. That's a requirement. So you say, okay, I want a 6 subnet, so maybe I need 3 bits for that at least. So it means you want you're separating the 3 bits from the left, from the 8 bits that you have here. So you're separating 3 bits. So okay, so this would be your subnet mask, because now you had how to say. You had this. This is the same with. Let me put the big pen. This is equal with /27. Okay. So then the first subnet is start from 0, of course. The subnet. Okay, this is not the IP address for the host, but the subnet. The second start from the next one, from 32, because now you have 3 bits for the host part. Then you have 5 bits for the, 3 bits for the subnet part. You have 5 bits for the host. So 2 to the power of 5 is 32. So basically it means jumps or difference between each subnet is 32. It's bit 32, okay? Let me see. So the next one would be the 32, and the last one would be 224. Because if you add 32 to this, then you get 256, the last one basically, the end of basically this bit. So is it clear so far?
Yes.
Yes.
So okay, 3 bits for the network, 5 bits for the host, so 5 to the power of 5, 32. So each jump would be 32. The size would be 32. So then the broadcast, easy way to fill up is you say, okay, this is my second subnet. So exactly the IP before this second subnet is my broadcast address. So you can say these are your broadcast address. Of course, for the last one is 255 is all one broadcast address. So for this one, 31 is the broadcast address, because then, okay, the confusion might come here and say, okay, 31 is not all one, but it is actually all one. 31 in terms of binary, okay, it's 0, 0, 0, 0, 1, 1, 1. Sorry, I confused. 1, 1. This is now 3 zeros. Forget this. 0, 0, 0, 1, 1, 1, 1, 1. It's like it's this is 31. So remember, these 3 bits are your network part. So we are talking, when we said all ones are the broadcast address, we are talking about the host part. This is your host part. So this is your broadcast address. This is the binary, 5 binary. I mean, like 5, 1 in the binary, you convert it to decimal, it becomes 31. So here you put the 31. So here for this one would be 3. For this one now you have 0, 0, 1. This is the network part, okay? Then 1, 1, 1, 1, 1. So you add, if you add all this together, you get 63 in a decimal. So again, all ones for the host part. This is the network part. This is the host part. Is there any questions about that? Okay. So then the first host would be, as you remember, the first host would be 1. And what would be the first host here? Here.
33.
33, yeah. 33. And the last host here, you see last host here is 30, the one right before the broadcast address. And here?
62.
62, right? Then all the way like this. Any questions about this? Any doubt?
I have one.
Okay.
Like when you send a packet, or well, yeah, a packet through the network and it arrives to the organization, it has to arrive first to the general IP of the organization, right? And then it goes to a subnet.
Okay. Yes, let's say.
So in this example, it says that the general IP address is 193.1.1.0. How do we differentiate that from the first subnet that is exactly the same?
You mean you're talking about these two?
Yeah, that one, the first one that is supposed to be from the the first subnet, yeah, the .1.1.0, and the
okay. I got your question. Let me raise this. So you're talking about a difference between these two.
yeah.
Okay. Okay, so you mean how you differentiate that this is the first subnet, but not the whole, basically, the whole network IP for all the IP that you have, right?
Yeah.
So basically, this also would be visible as I mentioned here. Now you have 224. Basically, if I go back, let me go back to this example here. Usually what we see usually is like this type of address, like this. So the suffix is there, or the subnet mask is there.
Okay, but the router, how does it differentiate it? Like, this is my address of the entire network, and this is the first subnet of the.
Even if you, for example, open the command line in your system, if you're using Windows type IP config, you can see there is subnet mask in your system.
Okay.
That is defined, the subnet mask. So basically, this prefix would be there, it would be visible.
Okay.
So you can say by looking at that prefix that what's happening there. Yeah, but that's very good question actually. That's very valid question. So okay, we saw this. Any question about it? How to do this calculation? So if no, about this. So here it's a little bit different now. Here we have different IP addresses, and then it's different, asking you different. For example, here I want 15 subnet. Here I want, for example, 15 host, 7722. Okay, this is different. But anyone solve this? Kevin, you said.
We missed the last two.
Okay, so did you compare my answers with your answer? Was it correct?
Yeah, the last one was correct.
Okay, perfect. So here is the same thing, a little bit different again. Here, for example, he's asking you, for example, you want to have 15 subnets. So you say, okay, I want to separate. How many bits you want to separate for this?
4.
4, exactly. Then your subnet mask would be this. Again, and this, I mean, don't get confused, please, with this. Okay, this is exactly same if I write 28, okay? Like /28. Okay, that's the same thing. So if you
Yes.
add like 1, 1, 1, 1, 0, 0, 0 in a decimal, convert this decimal to the binary, you get this number. So that's the subnet mask now. So if we have 4 bits for the subnets, 4 bits for the host, how many you get in the host? 14, right? 2 to the power of 4, 16 minus 2, 14 hosts. Then the first usable subnet.
The one that ends with 0.
Exactly. Second usable subnet.
The one that ends with 16.
Which one? 16?
The one that ends with 16.
Uh-huh. Exactly. And this is the second one, and the last one.
It would
The
be
one that
240.
Exactly. 240. So you
Like
get
the subnet mask, right?
So okay, this is a little bit more interesting now here. You want 15 hosts. So how do you do?
We would need at least, I think it's 5 bits for that.
Exactly. So if you separate 5 bits, how many subnets you're going to have?
8.
8.
8, 2 to the power of 3, right?
Right.
So 8, so it means 3, 1, so it means 1, 1, 1, 0, 0, 0, 0. So you add them, it will be this. If you put in the suffix, it will be 27. So then the first would be this. Then now remember here the jumps are 32 because you separated 5 bits. So 2 to the power of 5. The distances, basically the range are 32. 32 basically IP addresses or 30 usable hosts per subnet. So that's how it works. Any question about it? You want to do another example or like this one? Or let's go the last one. Let's this one. You want 50 subnets.
We need at least 6 bits for that.
Because 2 to the power of 6, 64, right? So you want
Yes.
it's 6 bits for the host. Then you left with 2 bits for the host, right?
Yes.
So how many hosts you can have?
Only 2.
Oh, I have to go all the way to reach her. So talking about this is 2, because now you separate 6, 1, then this is same with, I say, 30.
Right.
So the first usable subnet,
It's 0.
like 199.9990. The second one,
Right. Would
4.
be 4.
exactly. Now the jumps are 4, right? The spaces are 4. And the last one would be
252.
252, right?
Right.
So okay, that's it. I hope you understood what's happened here. What I do, I'm going to I put the same. I get a screenshot from here. I put in the same file that I shared with you. Okay. So I really recommend you don't check the answers. First, respond yourself, then compare it with the answer that I put and see if you get it right. Because again, if you don't get this one right, I'm sorry to say, it's gonna get even more complicated later because we haven't done the subnetting yet. Okay? Because this is so far what we talk about is like a fixed length subnetting. Then we're going to talk about variable length subnetting. That is even a little more complicated than this. But if you get the idea, it doesn't basically perfectly make sense if you get the core idea. So that's all about today. Any questions about the topic?
No.
Okay, so, okay, perfect. So we're done. Let me stop recording.